Okay, I'm sorry. I'm sorry. Yeah, anyway. Hey, lesson one, people. Generating equivalent expressions. Okay, so we're continuing with what we've been dealing with, which is that combining of like terms, making everything one happy family there. So, equivalent expressions, like we said, that phrase of simplify is really what we're going to be using, but hey, it all means the same thing. So, here we go. Rewrite 5x plus 3x and 5x minus 3x by combining like terms. Okay, so we want to combine them. So if you combine the 5x with the 5x, and again, we need the same letter with the same exponent. All right, and then we can add those coefficients together. Look at that, coefficients, huh? The number out in front of the letter. Yeah. All right. So 5x plus 5x is 10x. And then, oh, wait a second. I could have, oh, here we go. I didn't realize those were the exact same, but here we go. The reason why I saved those, because they are additive inverses. Yes, when I combine the 3x and the negative 3x, poof, gone. So, yeah, it's just my 10x there. Now, again, I could have done 5x plus 3x is 8x, plus another 5x is 13x. Take away 3x, and I'm at my 10x there. But, yeah, we can just jump right to it. Again, the plugging it in would just show that it's equivalent for that 4. Like I said, we can do it. It's nice to know it, but we're not going to be doing it over and over again. All right, find the sum of 2x plus 1 and 5x. So remember, sum means that we are going to be adding those ideas together. So again, I can combine my like terms. There's my 7x, and then there's my plus 1. Can't forget about the plus 1 just because we can't combine with anyone. Letters, and then just plain numbers at the end. So we don't want to say 1 plus 7x. What we call a standard form would be the 7x plus 1. All right, let's get into part C here. I see a negative 3a along with a 5a. So that's going to give me a 2a, negative 3 plus 5. I see a 2b and a negative 2b, wave goodbye, additive inverses. And then I see a 4 being combined with a negative 3. So yeah, 4 minus 3 is a 1. It's a positive 1. 2x plus 1, show is over. Again, if you plug in the negative 3 at the very beginning, you're going to get the same answer if you plug it in right there. It's a way of checking. Again, we're fine. Okay, now, here's where things start to open up. And we're going to go to, let's just go to D. Let's stay in order here. Find the difference of 6x minus 7 and 3x plus 4. Okay, there's that word and that is there. Now, remember, and does not mean to add, to subtract, to multiply, or divide. It does mean to subtract in this case because of this word difference that has shown up. So, again, and shows up to show you where that operation is going to go. So we've got 6x minus 7. We do want to realize that technically it's parentheses because they're a group. We're going to subtract them, and we're going to subtract these guys over here, the 3x plus 4. Now, we started to see this yesterday. Distribute the negative was the phrase. We talked about we can send that negative in to visit everyone. We also talked about you could slip a 1 in front of it and distribute your negative 1. Does the exact same thing. So when I rewrite this and clean it up, I still got the 6x minus 7, but now it's a negative 3x minus a 4. Okay, I used this subtraction sign. So it's not like, hey, let's bring it back again. It's been used. Now I'm ready to combine like terms. So a 6x with a negative 3x. All right, that's going to give me 3x, 6 minus 3x. I've got a negative 7 hanging out the negative 4. Combine those together, negative 11. So it's a minus 11 we're looking at. All right, distribute the negative here. Take a look at letter E. All right, yeah, there it is. Again, it's recognition. That's what a lot of this stuff is moving forward, is they're going to present the situation, and you've got to be like, wait a second, what do I have to watch for here? Well, hey, yes, that subtraction sign needs to visit everyone. So I'm going to rewrite here. So I've got the negative 8x plus 4. If I distribute the negative, it's no longer a negative 3x. It's now a positive 3x. It's no longer a negative 5. It's now a positive 5. Again, distributing the negative will change the sign, just like multiplying everyone by a negative 1. Now we can combine, so a negative 8x with a positive 3x. That gives me a negative 5x. And I'm combining that positive 4 with that positive 5. Hey, plus 9 because it is a positive 9 that we're looking at. All right, let's go to letter F that's here. One more of the same thing here. And hey, there's 3 people inside those parentheses, but make sure we visit everyone. So we're going to rewrite here. 5x plus 6y minus 3. Get a bit of y there. And then it's going to be no longer a negative 4x. I'm distributing that negative. It is a positive 4x. It's no longer a negative 9y. It's now a positive 9y. And it's no longer a positive 3, but negative 3. Whoo! I like, again, to circle, underline, box things. It keeps me focused, especially we've got a lot of things that are in here. Sometimes I even cross things off as I use them. So if I take the 5x with the positive 4x, I'm going to get a 9x. If I take the positive 6y with the positive 9y, I'm going to get a positive 15y, so a plus 15y. And if I combine the negative 3 with the negative 3, I'm going to get a negative 6, so it is a minus a 6. So there we go. There we go. 9x plus 15y minus 6. All right. Let's see what else we got going on here. All right. So, yeah, let's see here. Any order, any grouping and expressions with it. Okay, so now they're just starting to throw stuff at you where they want you to clean up. Remember, we're not going to worry about the substituting them in. This just says 3 times 2x. And sometimes when we go backwards and we're looking at something that's more straightforward, it's what throws us off. But yeah, there it is. Yeah, 3 times 2 is 6. All right. 4y times 5. Yeah, 20y. 4 times 5 is 20. That's there. Okay. 4 times 2 times z. Yeah. 8z. So part of what we're after here is, hey, number first, letter second, right up against each other, those type of things. Okay, let's look what's going on in B. 3 times 2x, okay, 6x. 4y times 5, okay, 20y. Can ya? No like terms. One of them's an x, one of them's a y. We can't here. All right, let's see what we got going over here. 3 times 2x, okay, there's that 6x. 4y times 5, well, just like before, it seems kind of familiar. 20y, let's see if anything has changed. 4 times 2 times z, hey, we saw you right up there. You guys are all the exact same. Plus 8z, all right? And yeah, there we go. That's it. Show's over. We can't do anything else because we do not have any like terms, all right? Hey, that's it there, people. We're done. Again, I apologize for the beginning, the scaring with you. I don't plan on doing it again. Well, I'm sorry, I couldn't resist. I'll see ya.